another South Dublin Radio Club lecture, and before I introduce Joe Ryan, EI7GY, I just want to say a few things. If this is your first time with us, you're most welcome. And if you're a return guest, thanks for your ongoing support. As with the other nights we've had so far this autumn, the aim of these nights is to educate and inform and to promote amateur radio as a great hobby and gateway to learn about science and technology. And these presentations are not exclusively aimed at the amateur radio community. Everyone is welcome. All presentations are recorded, and you can find our previous talks on the South Dublin Radio Club YouTube channel. And you can keep up to date with our activities on social media via Twitter, Facebook and YouTube. And I'll add the links to those sites into the chat in a short while. If you're a keen shortwave listener, you can keep up to date on our upcoming talks and events via the IRTS, HF and VHF news services. So the running order for tonight's talk is that we'll keep the audience muted for the duration of Joe's presentation. And then for the questions and answers session at the end, and to avoid audience members talking over each other, my colleague Derek will go to you for questions. So what we mean by that is, if you want to put a question to Joe at the end, just put your name in the chat function, and Derek will come to you and you can ask the question. And then just a reminder for next week, the plan is a Monday night talk next week at 8 o'clock. That won't be hosted by ourselves. It'll be hosted by Dublin Maker on behalf of Science Foundation Ireland. And there'll be a short video presentation on decoding weather satellite images. It's kind of a beginner's presentation as to how to get involved with radio. And there'll be a Q&A session after that. Okay, so on with tonight. It's a great pleasure to introduce Joe Ryan, call signs EI7 GY. Joe obtained his amateur radio license in 1989, and he's been a member of South Dublin Radio Club and the IRTS since then. As many of you know, Joe is the IRTS contest manager and is involved in maintaining the IRTS website. So Joe, you're very welcome to your own club tonight, and we're very grateful for your time and doing this presentation for us tonight. Over to you, Joe.
Okay, right. So I need to press share screen and select the screen. Is that right? Let's see. Does that one work? Yeah, that works. Okay, that's working, Adrian, is it?
Yeah.
Yeah. Okay, fine. Right. So I'm going to talk about radio experiments by Colonel Dennis, EI2B, Echo India 2 Bravo. And his efforts are of particular interest to us because he's generally seen as the world's first radio amateur. He wasn't by any means the first to experiment with electromagnetic waves for radio communications. I mean, there were plenty of laboratory experiments going on before he took to the air, as it were, and indeed Marconi was involved in developing radio communications for commercial purposes. But he's different because he began his experiments as a hobbyist. Maybe other people did, but he began and he continued to experiment as a hobbyist. So he was the first person to start as a hobbyist and end as a hobbyist, as it were. And this presentation is based on some research carried out about 18 months ago by Robert, EI5KH, and by myself. So let me see now. Yes, that's how it works. So just to talk about Colonel Dennis, he was born in County Wicklow in 1865, so whatever that is, 35, 50, 155 years ago, educated in England. He was born into a sort of, let's call it a military family. He inherited Fort Granite at Baltinglass, County Wicklow in 1891 on his father's death. Fort Granite is a fairly substantial estate, and I'll show you a picture of the house in a moment. I said he was from a military family. He served in the Boer War, and then he was based in Woolwich Arsenal on and off from 1901 to the end of World War I. But otherwise, he lived at Fort Granite. He was a founder member of the Dublin Wireless Club. That was in 1913. So I suppose that was the then equivalent of radio clubs that we'd all be familiar with, but they would have really been focusing on, building radios to listen to to probably to broadcast transmissions or to whatever was on the air. There would have been very few people making their own transmitters at that stage. There were some, but I think the name Wireless Club implies that it was more listening rather than transmitting. And in fact, the Irish Radio Transmitter Society that we now know is in effect a sort of a breakaway group. I mean, that's why the word transmitters is in the name. I mean, I often find it difficult to explain to people, why we're called the Transmitter Society. And I think that was really to distinguish us from the Receivers Society. So he was the first president when it was set up in 1932. He died in 1945, aged 80. So he lived a good life. There's anyone who's interested in the history of the family, and it's an interesting enough family because there are links going back to the Swifts, as in Jonathan Swift and so on. I've put the link there. A local historian, Turtle Bunbury, has done a lot of work on this family and indeed on a lot of other interesting things around the sort of Wicklow, Wexford area. I'm just going to go to the website. So I have that website link on the presentation, so that's there forever. So you can see he goes back to whenever 1711 or something like that. So now how do I get back to now what I need to see is how do I get to the, hold on. Oh, I got back to the slideshow. Okay, so that's that website there. If you're interested in going into the background, that's a photograph that I took when I was down there, one of the days I was there in 2019 of the house. Fairly substantial house, probably largely as it looked in Colonel Dennis's day. This bit here, I think, is a relatively new, except when I say relatively new, this was built sort of post-Second World War. This bit here at the back, but otherwise it's largely as it was. So you can see a fairly substantial place. And okay, since Colonel Dennis's death, Meade Dennis, Colonel Dennis's name was Meade Dennis. But anyway, so Meade Dennis, son of Colonel Dennis, lived in Fort Granite from 1947 to 1965. When he died, then the estate was taken over by his son Piers, who lived there until his death relatively recently. And the estate then passed to the three daughters of Piers. All grew up they were born and grew up in County Wicklow, but they're all living in the UK now. So they're great-granddaughters of Colonel Dennis. And they decided to sell Fort Granite. The 340 acres attached to it, it's a dairy farm, a very nice-looking dairy farm, had been let out. So that they had just retained the house, but I suppose it was of no interest to them anymore. So that was sold in 2019. Now the family was always conscious of the sort of heritage value of the papers and indeed the equipment that belonged to their great-grandfather. And they got in touch with IRTS and asked us to identify and secure the radio-related material. They didn't want that to just sort of go to the new owners. They got in touch with Robert, and he asked me to join him. And we spent a good few days down there in March and April 2019. Robert spent a good bit more time than I did. He went back several times after we had done our initial work. The radio-related material was mostly in a basement area and in a pigeon loft, and I have a few photographs coming up now to illustrate that. Now we were given more or less, free run of the house to pick up the radio stuff, and for the days that we were there were also staff from a firm who were involved in arranging a contents auction, because the house was sold without contents and they were auctioning the contents. So we were running around picking up the radio gear and tripping over these guys who weren't really all that happy that Robert and I were there, who were cataloguing the sort of the silver or whatever else that they found there. So here's a few photographs that we took, and these are from the basement. So you can see, I mean, it was, I won't say it was dumped there, because I mean, there was nothing particularly wrong with it, but I mean, it wasn't stored in shelves or anything like that. It was in boxes and bits heaped on other bits and all that sort of thing. So it's various things. You'll certainly recognize some of the radio stuff there. This was in a wine cellar. In fact, I think that box there had wine. We didn't touch the wine. There's quite a lot of wine there actually, but which we left alone. So really, some of it was there, and some of it was in pigeon loft. And this is Robert climbing up to the pigeon loft, and this is him up there. Okay, this was originally connected to the house. That's that new extension that I pointed out. But at some stage, the connection between that part and this part of the house was. By the way, Adrian, I assume the cursor can be seen. You can nod. Yeah, okay, fine. So the connection between there and the house was bricked up. So Robert climbed up. He put a mask on. Little did he know that 12 months later we'd all be looking like that. But so why did he have a mask and so on? Because it was full of pigeons, and you can just imagine what it was like. In fact, the first thing we had to do was to throw in a few rocks to sort of get the pigeons to vacate the place while he worked up there. He crawled around there and picked up what he could and put it in that red bucket there and sort of dropped it down to me. So that I just thought it would be interesting to see the work that we had to do to retrieve quite a lot of this stuff. This is something actually, this here, which is some sort of ATU, wasn't in the pigeon loft. As you can see, it was in the house itself. I would imagine it was there. It wasn't in the basement either. It was there sort of almost as an ornament. So anyway, the main thing we had to do is, I think by the 30th of April or whatever, we had to get it out of the house and into it. There was one outhouse that was sort of excluded from the auction of contents, and we had to get it into that. And this is the outhouse here. And this is a photograph of just a small amount of the equipment that we transferred in there. So now IRTS had no way of storing the equipment or displaying it. I mean, we could certainly have rented storage, and indeed the Dennis family was prepared to pay for storage if needs be, and they had arranged with a local farmer to carry it to storage. But we would have had no. IRTS does not own any premises. Most of the people here probably are members of IRTS, so you know that there was no point in us taking it. It would simply lie there for the next whatever number of years. Unfortunately, the Computer and Communications Museum of Ireland, which is based in NUI Galway, indicated an interest in acquiring, maintaining and displaying the equipment and papers. And actually Frank, one of the CCMI representatives, is one of the attendees at tonight's presentation. So the family were very happy with the CCMI's proposal. They agreed that we could scan in the papers and publish them on our website. And then the equipment and the papers were transferred to CCMI in, I think it was April 2019. So just people will be interested in, people who are not familiar with CCMI may be interested. So this is just from their own website, founded in 2010. The CCMI tells the fascinating story of key moments in the history of computing and communications. We explore technology by preserving the past, demonstrating the present, and educating for the future. So it's a not-for-profit limited company. It's partnered with Insight Centre for Data Analytics and NUI Galway. And just a comment by, I'm not sure whether it was by Frank, it was by someone from CCMI, in an email to Robert within the last week or so, talking about the EI2B collection. The few jewels that we find are inspiring and show the depth and breadth of Dennis's interests. We restored some objects and are working on others. Obviously, the work that they would have been doing, in preserving it and getting it ready for display, will have been impacted by the current health situation. This is just two of the photographs they sent. Actually, this one here on the right is a piece of equipment that you saw in a much more distressed situation in the photograph in the montage of photographs that I showed from the basement. And this is a link to the CCMI website, which it's quite an impressive sort of thing they do. Obviously, an emphasis on computers and on communications. So I think, you know, worth a visit, and we are certainly looking forward to, you know, to seeing the Dennis collection, as it were, going on display. But that clearly has been held up. So onto the sort of, you know, what started Colonel Dennis down the road of becoming a radio amateur. So, I mean, he didn't invent radio. The science behind using electromagnetism to sort of send signals through the air was developed over the 19th century. There's always some dispute over who invented radio. It depends what country you're from and so on. Marconi was certainly, he certainly didn't invent it, but he was the first maybe to see the commercial opportunities. You know, he saw it as more than just an interesting laboratory experiment. And he was quite good at sort of promoting, you know, his business. He clearly needed, I suppose he needed to raise money and so on. So he was big in promoting things. And he was in July 1898, he attended the Kingstown Regatta. That's Kingstown is now called Dunleary. And he had a yacht, Electra, I think is the name of it. And that yacht was out in Dublin Bay. And, you know, he was at the committee boat, I guess, for the end of the race. And he, you know, that boat then transmitted the results back to the Harbour Master House in Dunleary, and they were able to send them by landline to the papers. So whereas normally, you know, the papers would have to wait until the committee boat comes into the harbour. That could have been an hour and a half, or whatever. So you know, he showed how radio could be used to get news fast, and it's possibly the first use of radio in sports reporting. But anyway, in fact, in July 1998, I was with myself and Paul O'Kane, by arrangement, we're on a boat out in Dublin Bay, and Paul, most of you would know Paul, being the CW guy, he sent some messages back from our boat, you know, to celebrate the 100 years, the 100th year anniversary of this. There was no regatta on or anything like that, but it was a good sort of way of, you know, of promoting amateur radio. So Marconi was obviously in Ireland then around that time. And in August, you know, just the following month, in August 1898, at the RDS Kildare Street, Dublin, Monsignor Malloy, who then was rector of the Catholic University in Dublin, which is now UCD, gave a lecture entitled Signalling Through Space by Means of Electric Waves Without the Aid of Wires. And just by the way, as a matter of interest, I was curious when I read about this. I was curious to know where exactly the RDS in Kildare Street is. And I asked a friend of mine who's a member of the RDS, that's the Royal Dublin Society, and I was told it's Leinster House. The RDS headquarters had been in what we now know as Leinster House, or which now houses the Dáil, the Irish Parliament. And it was when we got our independence in 1921, December 1921, the government was keen to have a place bigger than the Mansion House, which had been used for the Dáil meetings before independence. So they persuaded the RDS to sell it to them, and the RDS moved out to move their headquarters to land out in Ballsbridge, which they had owned. Anyway, that's only an aside. So at that lecture, Marconi gave a demonstration of signalling through space without the aid of wires. Colonel Dennis was one of the attendees. He was in the audience, and basically he went home to carry out his own experiments. And on another aside, Monsignor Malloy had previously, before going to UCD, he was a professor at Maynooth, and another professor at Maynooth many years earlier was Nicholas Callan. Now, Nicholas Callan is the inventor of the induction coil. That's from the 1830s, and that's really what sort of facilitated experiments in, high voltage sparks, and because the induction coil was the way of building up high voltages, and that's what was needed to generate electromagnetic radiation. So this is just a small piece from the Irish Times of the 25th of August, 1898. It's always interesting to see how these sort of events were reported at the time. So in case it's not clear on everybody's screen, I'll just read the first paragraph. On Tuesday evening, a large and fashionable audience assembled in the theatre of the Royal Dublin Society to hear a lecture by the Right Reverend Monsignor Malloy, the subject being signalling through space by means of electric waves without the aid of wires. A special interest was added to the occasion owing to the announcement that Senor Marconi would attend and that his apparatus for wireless telegraphy would be exhibited. So, as I said, Colonel Dennis, was there. He decided to go home and try this out for himself. Now, he wasn't a scientist. So, I mean, he didn't sort of, open a log or make notes at the time of the results of his experiments. But it's obviously, it seems from the next slide that I'll show you that it was many years later, he knew he had done it. And then many years later, I suppose he realized the significance of what he had done, given that it was just 1898 before anyone else was really doing it from a hobby point of view. So, I mean, I came across this letter here. This is from the Marconi, it's from the Marconi company. Obviously, he wrote to them. We're talking about 1929, so we're talking more than 30 years later. And he clearly asked them, when did Marconi, attend Dublin to demonstrate his transmissions? So they said maybe July 1898. They were out by a month. And then Colonel Dennis, in his own handwriting at the bottom, says it was after attending this lecture that I made my spark transmitter and receiver, Coherer, probably the first amateur set ever made. Now, he was doing this for a reason, because, as I show you here, he wanted to sort of document it in his notebook, and I will explain later on in more detail about this notebook. So he has this page in the notebook. And again, his writing is difficult though after several weeks looking at it, I'm beginning to be able to read his writing. But anyway, he has photo of Coherer built by me in July 1898 that was used with a 4-inch spark coil and worked up to 70 yards. Again, he got the month wrong. There seems to have been confusion, but the Irish Times article is definitive. And down here, he has the base of the box contained the dry cells for operating the Morse sounder in the foreground. Now, he sent that, or a copy of that, to the TNR Bulletin in June 1931. The TNR Bulletin was basically the RADCOM of its day, the RSGB Bulletin, TNR being the transmitting and relay section of the Radio Society of Great Britain. This is actually, I'm sure the RSGB won't mind if I just show a small extract from the TNR Bulletin of September 1931. And this is really their report based on the information that they had obtained there. And they just comment at the end, the original apparatus is still in existence at EI2B, referring there to his QTH. And the photograph is reproduced herewith. Next, please. So you can see that it was many years after the initial experiment that he decided to, this is important, I need to document this, and that's what he did. So I just thought it was worthwhile showing a circuit diagram of a simple sort of spark gap transmitter. Maybe there's someone watching who will have a better idea. But anyway, okay, you need an induction coil to build up the voltage to make the spark. Well, you need a battery, I guess, for a start. You need an interrupter or something that will, basically give you a sort of AC, as it were. The coil will only work if there's AC. So there were various schemes, mercury switches and whatnot, used to alternate or to break up the current, and then a Morse key. So the transmitter was fairly, well, it was simple, if you knew what you wanted. The receiver was actually a little bit more complicated, because I think the same applies now. I mean, I have made many CW transmitters in my day. They're pretty easy to make. It's the receiver is the hard part. But anyway, so at the time in 1898, the only way they had of detecting electromagnetic waves was using a coherer. And to describe a coherer, actually, I'm going to use the words in that Irish Times article that I showed earlier. They quoted what Monsignor Malloy had, or how he had explained a coherer, and I thought it was actually a pretty good explanation, because you can get lots of explanations of them. So he described the coherer as a glass tube filled with brass or copper or iron filings. In normal conditions, the tube was practically a non-conductor, but when struck by the electric waves, it became a fairly good conductor. No sooner did the electric waves come in from a distant station than the filings were welded together by the action of the waves, and they became a conductor. So here's the coherer. This is the glass tube. It should really be a vacuum, or a near vacuum anyway. And these are the sort of iron filings. So then in a vacuum, they'd be in a sort of a random place. That's the theory anyway. And, when the electric waves hit them, they sort of cohere around a particular point. It wouldn't necessarily be the middle. I just thought it was easier to draw it that way. And okay, so you've got a battery here, and nothing happens when there are no electric waves. When the filings cohere around a particular point, you make the circuit, so then the relay is activated. Then you've got another battery, and of course, when the relay is activated, the switch goes down and the bell rings. And the only problem with the coherer is that when you take away the electric wave, your dot or your dash or whatever, it doesn't tend to uncohere. The filings just tend to stay where they are. So you needed a decoherer, a tapper. Again, there were various pieces of equipment. It could be, you could be doing it by hand, or I think, it would have been a mechanical tapper at so many times a second or whatever, to force the thing to decohere. So that's, a very basic coherer receiver. So here's an interesting one. There is some disagreement over where the first transmission took place. In 1998, the RSGB, that's not all that long ago, the RSGB published a book called Amateur Radio, The First 100 Years. And in that, they say the first recorded amateur radio station is that of MJC Dennis in London. This is our colonel, in 1898. Having heard of the experiments performed by Marconi, he was so impressed that he immediately started up some of his own experiments. As he was stationed at Woolwich Arsenal in East London, he set up his station there. Now, we've discussed this with the Dennis family, and they say, well, he wasn't in Woolwich Arsenal in 1898. He wasn't near the place. He was living in Fort Granite at the time. They would know from the records, because when he wasn't at Fort Granite, the estate was leased out to farmers and that sort of thing. So they're positive that he was in Fort Granite in 1898. In any case, his own note, Colonel Dennis's own notes that I referred to earlier, imply that the transmission was done at Fort Granite. And interesting enough, in fact, the RSGB in their own bulletin of September 1931 added a bit there about the original apparatus is still in existence at EI2B. And as us radio amateurs know, that we use the call sign to denote ourselves and indeed to denote where we live. So all I can, and this is my own assumption, the confusion may be due to the fact that he was in Woolwich in 1910 when he got his first call sign, but that's nothing to do with his first transmission. Call signs didn't become required until about 1904. So I mean, well, there was no such thing as amateur, well, as any radio call signs in 1898. So we're fairly certain that the first ham transmission took place in County Wicklow and not in London. So I mentioned the papers that we obtained from the Dennis family, and they agreed that we could scan them in. There are there's about 400 pages of altogether. So there's a lot of stuff there. Now it's by no means a complete record. There's a scrapbook which is a complete record, shall we say. It's his own scrapbook, but there's correspondence, and there are you know, various bits and pieces that are incomplete. He kept almost no copies of letters he sent out. I suppose that would have been more difficult for him, but there isn't even a complete record of letters received. But still, I mean, it's pretty good for something going back to, you know, the sort of the 20s and 30s, 100 years ago, more or less. And we've put them on the website. Does that go to that? It does, yes. So this is how it's presented on the IRTS website, and there's the scrapbook there. So what I was going to say, that he did an index, and in fact the next slide, I'll show you the index. So we simply took his index of the scrapbook and we reproduced it, and it's clickable. So this is the index which we copied from his own index, and what I was just showing the example. Let me see if I can. Yeah, that's the correct one. So there's the his notes on a condenser that he built. Well, he wrote the notes anyway in August 1910. So you know, you couldn't just go out and buy a condenser in those days. You had to build a lot of the components yourself. So and he also he copied you know, things from books and all that sort of thing. He cut them out and put them into things. So it was his sort of his internet, shall we say, of the day. So I'll see if I can go back to the presentation. Am I back at the presentation now, Adrian? Am I?
Oh, you're still on the web page.
It's okay. This is fun. You are okay. New share. So to go back to the presentation, I need to go to PowerPoint. Share. Okay, yeah. Why does that?
Yep, that's good.
Yeah, okay, fine. Okay. Oh yes, this I mentioned, he had an index and his scrapbook, and it was in one of these A to Z books, and there's these A's and there's these I's and K's and all that sort of thing. So that's just to show you the level of detail that he went. When we saw this scrapbook, we really knew that we had struck gold. I mean, this is absolutely fantastic stuff, and I can't in any way in a presentation like this do justice to it. So I just picked out just a small number of headings here that I'll talk about for, you know, in relation to his experiments. So there are the headings. So circuits and components. So this is actually his circuit. He calls it transmitter connections. Oh yes, different ways of connecting a spark gap transmitter. So I mean, that part there, you know, the spark gap, the secondary, the primary, the mercury break, that's the interrupter I was talking about, the battery, the key, very similar to the sort of simplified circuit that I showed. But here they were using an inductance now to sort of tune the thing, because the way I showed it just simply transmitted on whatever, you know, it depended on the gap and all that sort of thing. But here you actually had a way of tuning the thing. Why have I gone? Oh, it's gone complete. No, it's okay. Yeah. So, and he has notes here. I just thought I'd read out them just to show the sort of detail that he was going into. I have not found it possible to obtain as sharp tuning with this arrangement as with the inductive coupling at all events, if the latter is at all loose. It may give us sharp tuning as very close inductive coupling. I'm not now using this method of coupling. And then over here is the sort of inductive coupling thing, where he has details here about L1 and L2 form that, you know, so it's just a different way. I mean, any of us here, you know, who've been involved in making radios will understand this. I mean, he uses that sort of symbol there that we might use for a resistor now, but that's a coil. So this is his inductive coupling of a spark gap thing. So again, I just use that as an example of, you know, the sort of thing that he was grappling with, shall we say, in his experiments. And then on receiving circuits, this must be, well, he mentions an electrolytic detector and also crystal detectors. So this would be possibly post First World War, I think, because here they had moved on to, you know, beyond coherers. I mean, the coherers certainly didn't outline. I mean, the coherers were gone before the First World War. There were electrolytic detectors and then crystal detectors. So here he has a circuit describing, I suppose, a little bit like a crystal set that some of us might have made many years ago. And he, what does he say here? Figure 1 possesses no special advantages, and the 3 sliders on the EL coil are objectionable. Don't know why I use that word, but anyway, figure 2 is simpler and better and is one of the Telefunken arrangements. Either may be used with the electrolytic detector as shown, or with crystal detectors requiring a battery. Resistance of phones for electrolytic as high as possible, and for most crystal detectors low. So that's his crystal set, shall we say. He seems to have done a lot of home brewing of crystals. He was big into crystal detectors, and in fact, I have some slides later that show the number of different sort of minerals that he experimented with. But here's his description of an electrolytic detector. These are quite complicated things, because you had to, well, I think the electrolyte was a sort of slightly acid thing, so you had to use platinum. Anyway, he said it was used with sealed points made by H.W. Sullivan, 19 Great Winchester Street. So, obviously would have had to, you don't get platinum, in the local shop. In fact, there's quite a lot of correspondence with H.W. Sullivan, on in the papers that are on the website. And at the bottom there is the sketch of a small experimental detector for use with crystals I made for Mr. J. Shaw. So again, he wasn't buying components as we could do. He had to make them. This is a circuit that probably a lot of us would recognize. It's a tuner. I mean, we might call it an ATU. I think in these days, and I mean, this may be from the 20s, let's say, he was probably using valves in the receivers, but they would have been. I mean, there were superhets around, but if you were making them yourself, I would imagine it would have been just simply ordinary, TRFs, basically fairly straightforward and not particularly selective things. So there was a big emphasis on the RF end, on having tuning stages. In fact, my first radios were crystal sets, and I found that all I could ever get was Radio Earn, and I wanted to listen to Radio Luxembourg, and I kept building more and more RF stages, so I had 3 or 4 stages of tuning before the radio. It still didn't work. All I got was Radio Earn until it shut down at 10:30. But any of us here who've made any of these things can relate to it. We've got coils, we've got capacitors. It's an incredible amount of detail here in the taps, area inductance, the earth inductances, the coupling coils, and so on. So I mean, this is a full-time hobby for him. I mean, at this stage, I guess he was retired. So anyway, that's just another sort of example, as I said, of the sort of work that he was doing. And here we have some. This is what he said is a shortwave receiver at GW11B. That was his call sign here, and I do talk about his call signs later. But so here's his shortwave receiver, definitely a TRF type circuit, and this is adapted from Australia on 2 valves from the wireless constructor in August 1926. So I suppose that probably dates this thing here. So is an adaptation, and here he has a diagram of a crystal transmitter. This is, I think, the next page of the book. A diagram of a crystal transmitter for 45 meters, and he was working on 42 and 21 meters. And he has the in red there, he has the sort of amendments, the changes that he had to make to work on those bands. I'll talk a bit about it later. The frequency bands that amateurs were using would be somewhat different to what we're using now. So again, a lot of home construction, but I mean, it is a circuit that I guess we could sort of recognize. And here he has his dimensions of his aerial at Fort Granite, which, interestingly enough, he gives in feet and meters, which I thought I'm a fan of using meters. Anyone who knows me knows that I prefer to think of areas in meters because wavelengths are given in meters. So A to B was 13.6 meters, B to C is whatever, is it 9.3, and C to D is 6.4 meters. My only thought when I looked at that was, if I had that house and 300 whatever it was, acres, I think I'd put up a lot more wire. But anyway, that's maybe he did. Maybe he had other antennas, but that gives some sort of idea as to, you know, what he was playing around with anyway in the mid to late 20s, perhaps. This is interesting. He spent a lot of time, and probably a lot of early radio amateurs would have spent a lot of time working on detectors. Here we're talking about detectors for receivers. So there was the Coherer, there was the Electrolytic detector, and then there was the search for the perfect sort of semiconductor, you know, getting sort of, I think they knew that, you know, you got two different types of minerals, you know, and if you get the right combination, you've got yourself a good semiconductor, and that will be an effective detector. So there's a reference to zincite, which is some sort of zinc oxide, cassiterite, which is tin oxide, and you know, about the different signals and ferrous signals were obtained from this, that, and the other. Some things that we'd recognize, silicon, you know, it was, you know, I think we now know that silicon is used a lot. Well, I suppose silicon is very cheap and very widely available. There are some other things, getting graphite. Tellurium would be much rarer and you know, more difficult to come across. Molybdenite, but I mean, here we've got silicon, which we now know is used in modern semiconductors, and we have molybdenite, which is used in integrated circuits. So I mean, some of the work that he was doing, and I'm not saying that he was doing any original work on this, but he was buying. I don't think he would have got these locally. He was obviously acquiring quantities of these and experimenting himself with them and writing up notes in terms of, you know, what worked well and what didn't work. And in fact, on the next page, he has here, you know, the following detectors have been tried, but none were found equal to zincite tellurium or zincite bornite. But anyway, he has tried and gave signals. So here he has, you know, the things he tried: zincite with bornite, with tellurium, and all that sort of thing. So I mean, this was a huge amount of, you know, fairly fundamental sort of research, and then he has tried and gave no results. So I mean, this is sort of very interesting stuff. I'm sure there were others doing experiments like that, but I doubt if they were doing it as part of a hobby. So that's those previous two pages there. The previous two slides were about crystals for receivers. Now, crystals were also important to sort of for transmitters, you know, for frequency accuracy, and it's quartz crystals that that were used. And I remember they're still used. I remember when I got my license in 1989, one of the conditions of the license was that, you know, if I had a crystal control set, that I had to have a certificate, you know, in a form acceptable to the minister, that, you know, as to the accuracy of the crystal. So there's a lot of stuff in the EI2B papers about, you know, where it's correspondence backwards and forwards with the National Physical Laboratory in Middlesex, who are obviously, you know, he sent the crystals over to them. He would have been getting this himself. I mean, Baltinglass in County Wicklow is very much in a sort of a granite quarrying area, and anywhere you get granite, you'll also get quartz. So it'd be fairly plentiful down there. And we know from talking to the family that, I mean, he was out. My screen has suddenly gone black. Sharing has stopped as the shared window is closed. I must have pressed a button there. Hold a second. Sorry about this. Am I back, Adrian? Am I?
Yeah, that's good.
Okay. Yeah. I'm pressing the wrong button here, I think. Okay. So anyway, I was talking about the quartz crystals. There are numerous. So he was getting the crystals. You know, he was grinding them himself and maybe testing them on on his own equipment, which wouldn't have been up to standard. And then he was sending them over to London, you know, so that they could be, and they were giving him a report, and then he knew what frequency was working. This is a photograph. That's Robert's hands, I think. This is a photograph of some of the crystals that we came across down there in Fort Granite. And this is just an extract here from the TNR bulletin, right until Ireland left the Commonwealth and became a republic, would have reported on activities in the Irish Free State on a monthly basis. And here's a comment here from the TNR bulletin, July 1936. It's a report on the on National Field Day, and it says the personnel at B Station, which was in British, I think, greatly appreciated the visit from EI2B, who with supplies of crystals sufficient to cover all amateur frequencies, drove over from Baltinglass early on Saturday and spent the greater part of the day with us. So, he clearly was well known in Ireland for being able to, for producing crystals and so on. Okay, just on licensing, just one or two slides here on this. Here he was dealing, and here's 1920. Okay, so he's dealing with the GPO in London. Ireland was part of the UK in 1920, and they gave him a license just to receive, for the purpose of conducting laboratory tests and experiments without an aerial. It wasn't to transmit outside his premises, as it were. It was to to receive and just to transmit without an aerial. Then we got our independence in December 1921. So here we have June 1922, just shortly later. He's now dealing with the GPO in Dublin and being addressed as a Gwynna Usul, and they're giving him a license for receiving signals for experimental purposes. And there's a letter there of in 1924, I think, and it has where is it now? Oh yes, you have to add that the question of granting transmitting licenses to experimenters will receive consideration in due course. So they weren't issuing experimenters licenses at that stage. So that's dealing with the post office in Dublin. But then I looking then at some correspondence from 1925. Okay, here we have again the post office in Dublin. And at this stage, they've provisionally given him a license to transmit on 150 and 130 meters, and 150 to 200 already allocated. And it's regretted the use of other wavelengths cannot be allowed. So in those days, we were fairly restricted as to what we could transmit on. And then, okay, your request for permission to communicate with places outside on Saorstát is still under discussion with other government departments concerned, and so on and so forth. So that was that. But what I found very interesting, okay, so that's the 10th of September 1925. And here we go, the 10th of September 1925 from the GPO in London. I'm wondering, what's this all about? And what they're saying here is, I'll read it from this, it's easier. This is the GPO in London. The question of granting you permission to conduct wireless experiments with stations outside the Irish Free State, which, as you are aware, involve issues of a general character, is being considered in consultation with the Irish authorities. So, okay, we had a degree of independence, but clearly one of those things is that, people who are licensed to transmit in the Free State, that London was reserving the right, as it were, to allow them to transmit to stations outside the Free State. Now, that was news to me. I didn't know that until I started looking at this in more detail. So it's just an interesting little piece of history. I'm not sure what happened to it because there's no other clues within the documentation that we have as to how that was resolved. But when we go to 1929, for example, we have, and this is just Dublin here, they're giving him temporary permission to operate on 28.1 to 29.9. This is a band now that we would sort of recognize just for a temporary period for the purpose of specific tests. So by then there was no question of, this is subject to London or anything like that. So clearly that matter had been resolved. And just to talk about, I was interested in these 28 megacycle tests. So I had a look at the RSGB magazines from that period, and this was a test that seems to have been run by the RSGB, and it was to determine if simultaneous reception of distant stations is obtained in different places in Great Britain. to determine the comparative effectiveness of low power and high power, to determine the possibility of communication with other continents, to determine the suitability of various transmitting circuits, to determine the practical value of amplification at signal frequency on the receiver, and to determine the possible relation between solar and magnetic conditions and propagation. So I think here was something that was clearly organized by an amateur group, and that was the Radio Society of Great Britain, to see what 10 meters, as we would now call it, could do. The amateurs didn't necessarily discover the shortwaves, but I think they were at the forefront of establishing what could be done with them. They weren't completely on their own, but don't forget that a lot of transmissions were on much longer wavelengths than the bands that we would now regard as HF. And the amateurs were certainly amateurs in Europe, and indeed in the States, were certainly at the forefront, if not ahead, on establishing that these useless shortwaves, as they were called once, in fact were fairly useful. And in fact, in terms of the frequencies used, we had a presentation from Grimton, the Swedish station there a few weeks ago, and I think he mentioned 17.2 kilohertz as being the frequency they operated on. And I just found this in Colonel Dennis's notes. This is called Clifton. The wavelength used at Clifton, County Galway, in transatlantic work are 14,000 and 21,000 feet. And brackets, letter from Marconi Company to me, 18th of June 2010. So I've never seen wavelengths expressed in feet before. So I've done the calculation. 14,000 feet is 4,267 meters, 70 kilohertz. 21,000 feet would work out at 47 kilohertz. So these are the sort of wavelengths that were being used, admittedly now before the First World War, but you can see then by 1929, the amateurs were certainly trying to see what wavelengths like 28 kilohertz would be. Okay, so I said I'd talk a little bit about call signs because this is of interest. I think call signs became mandatory in the UK in the early 1900s. I suppose before that it was just a free for all. There were still few people doing it. Colonel Dennis got the call sign DNX when he was in Woolwich in 1910, and then while he was living in Ireland, the call sign he was given was 2HY. And then in the Free State, he was given the call sign 11B. And I think the tradition at the time was that amateurs used a sort of a prefix, or amateurs certainly in Ireland and England used a prefix. We used GW here. GI was in use in Northern Ireland then, but we had GW, which I can only assume like the W was for West, but it's now Wales. So the call signs that we know today came in January 29 as a result of the Washington Convention of 1927, which actually for the first time recognized the amateur service as a specific service. It also allocated bands that we could sort of recognize now, like 80 meters and 40 meters and 20 meters and that sort of thing, and call sign prefixes. And it was EI for the Free State, and that is there was no GDPR then, so that's what the call book, that's what the first EI call book looked like. And as you can see, Colonel Dennis had the first call sign, and it went all the way to EI4D. So bringing in these call signs was a major thing because there was total confusion in call signs before that. It was almost like you could just make it up. And in fact, to illustrate that point, this is an extract again from a TNR bulletin report. I can't remember what year, but it's before 1929. And this is a list of calls here. It's the sort of thing that you'd see in practical wireless or something like that now. But, so in America, there are all these 1AB, 2AFN, 5UK, 2ZB, relatively meaningless. I do see an N and a K there, which the US still uses. Australia, 3BO. Brazil 1AB, New Zealand 4AR. So I mean, you had no way of knowing from the call sign where the station was. In fact, the only country with any sort of consistency I see is Sweden, and it's interesting that that had, it didn't have any number in it, but they were all SM stations, and SM is one of the prefixes that Sweden has now. But all of the others were just, as it were, all over the place. So no way of knowing what it was from. So this is my last slide, Adrian. This is actually the cover of the very first TNR bulletin. So as you can see, it's the transmitter and relay section of the Radio Society of Great Britain. It became the RSGB bulletin in 1942. I suppose they dropped this idea of that. I mean, the whole thing about relays, but it was that, I suppose, transmitters had very, very short range. So any sort of long range communication involved relays. And you will be aware that the American National Society, the Amateur Radio Relay League, still has the word relay in it. So that's the connection with that. But just a couple of things that I as I said to you, they reported on activities in the Irish Free State until it became the Irish Republic. Well, I suppose really until sort of the outbreak of the Second World War. And a few things that I picked out here as just examples of reports about Colonel Dennis. August 1926 in the Irish Free State, reports are not numerous, but it must be remembered that all GWs, that would have been us here, are using less than 10 watts, and therefore they can't be expected to be QSO Australia every night. But their 10 watts gets out all right. 11B has been working the content regularly in the evenings and has been QSO P3FZ on 0.6 watt. Now this one I was particularly interested in, and I put it here, November 1927. 11B has nothing special to report. He has been trying to accumulate data for the minimum working distance for 45 meters after dark, which in his case appears to be about 1,000 miles, as a large number of stations have been worked at distances in excess of this after 2100, but practically none at appreciably short distances. Now, why I'm interested in this is it's only, was it the second Sunday? It was just a few weeks ago in October. We had our 40 meters counties contest, IRTS counties contest, and band condition. There was just no short skip at all. It was all long skip. I managed to work 3 counties, I think, Dublin, Kildare, and somewhere else, Wicklow maybe. So, it was almost impossible for stations in EI or GI to work counties beyond their own and adjoining counties, but we were able to work over to Britain and indeed to continental Europe. So, in 2010, we had problems with the skip on 40 meters. Okay, he's talking about 45 meters, but presumably very similar propagation. So I was glad to see that nearly 100 years ago, things were just as bad. And in fact, in the following month, it reports 11B is still concentrating on obtaining data for skip distance, would welcome reports from stations under 1,000 miles distant on his signals between 20 and 24 GMT. And January 28, he's still in a skip investigations, has been cutting and grinding quartz crystals with rather unexpected results. So that's me. You can stop me sharing now, or maybe I have to stop. I have to stop sharing.
That's right.
Is that right? Yes. Okay. Right.
No problem.
Stop share. Yeah.
Yep.
Okay.
Thanks a lot, Joe. That's a really amazing presentation. Considering the wealth and documentation on artifacts that you really only came to grips with last year, that you've managed to put that together in such a comprehensive way, although I'm sure there's a lot more to go through, and to flesh out exactly what Colonel Dennis was up to. But it's amazing to see his life and work tracked over the years from before the turn of the century to well up to before the Second World War, I suppose. So we'd like to invite questions now. So if you'd like to ask Joe some questions on the presentation he's just given, if you put your name in the chat, Derek, my colleague, will go to you, and we'll unmute your mic and you can put the question directly to Joe.
We just have a comment here from Roddy. Brilliant talk, great info. Thanks, Joe. That's Roddy EI2B.
Yeah, well, thanks, Roddy. Yeah.
We're just waiting for some comments to come in, but yeah, it was a great presentation, and I must concur what Adrian said about the amount of data you got aggregated together to give you certainly did dig into it. It was very good. Colin has a question. I'm just going to unmute him now. Okay, Colin, you can go and unmute yourself there.
Colin.
Go ahead.
Great presentation, Joe. Fascinating. You mentioned that the National Physical Laboratory in Middlesex,
Yeah.
he was exchanging crystals back and forth.
Yeah.
So he had a tight contact with them. So I'm wondering where his education came from in the UK. Did he work for the physical laboratory at one point? Or where was he educated, or his family?
No, I mean, you can take it. Well, okay. I don't think it's anything to do with where he's educated. I mean, I assume he was educated in England, and most people from those sort of army families would have been educated in England at the time. Though I can't be certain of that. But no, they weren't doing this for nothing, because in fact, the correspondence is on the website column, and if you look at it, you will see that they were sort of saying, that's 10 shillings, please. I mean, that was a service that they were doing for anyone involved. I mean, not just for radio amateurs. I would imagine that radio amateurs were a tiny part of their business, but for anyone who needed quartz crystals, who needed to find out, whether they worked and what frequency they oscillated at, and all of that, with different capacitances connected, was using them. So it was simply a service that he was using. I don't think he was using any special connection there.
Okay, thank you.
Right, so thanks, Colin. Any questions from anybody there? There's nothing coming
Joe,
up.
can I ask a question? And this is just from an ignorance point of view. Why were early amateurs and radio experimenters confined to the lower frequencies at the start of all this?
Well, it would be mainly technical, Adrian. This wasn't necessarily, that any sort of regulatory thing. Don't forget that, getting to higher frequency, there simply wasn't equipment available that would, generate signals at high frequencies. I mean, it was a technical limitation more than anything else. I mean, the initial experiments, because it was spark gap, just simply worked out that's going to give a very, very low frequency signal. And even when, you saw the equipment in Sweden, in Sweden, and that's a mechanical. They generated the electromagnetic waves mechanically. Now you can imagine you can do something at 17.2K. You couldn't do it at 29 megs, sort of thing. It would have to spin too fast. So I mean, I don't think that. I don't get the impression that there was any regulatory constraint. It was a technical constraint on, not just on amateurs, on everybody. Yeah, there was probably a lack of understanding. I mean, we now know about propagation, and we've got satellites flying around, and we've had rockets going up, and measuring all sorts of things. So I mean, we have an understanding of propagation layers and all that sort of thing that simply wasn't around at the time. As you can imagine, initially they assumed that this is going to go like light, it's going to go in straight lines. So the fact that you could ultimately contact Australia from this side of the earth, I mean, I would imagine in many cases they didn't understand how it worked.
Yeah. And is there, just on a follow-up to that, is there any evidence that, say, the experimentation that he and others were doing at the time was fed into some sort of formal gathering point, either in universities? Was there someone taking advantage of what they were doing? Did you find it?
Well, I'd be surprised if there was. Yeah, no, I understand the question. I mean, there's nothing in the papers, and there's nothing. I'm not a historian or something like that. It's an interesting, but that would actually be an interesting subject for someone's thesis or something like that. And I think that the papers that we've put on the website may help, because it just might fill in some gaps. But I mean, that's an interesting point. I mean, I would imagine probably yes. I mean, those 28 megacycle experiments that I mentioned there, I mean, I would, I take it they published their results. It's not something that I've particularly researched, but I'm sure others in industry and so on took note.
Okay. think there's another question there, I think, from Tony, 7GUB. Unmute yourself there, Tony.
Tony's muted, yeah.
Where did you go, Tony?
Yeah, okay, Joe, thanks for the talk tonight. Just his military background, and would you have heard or known of the first broadcast, the War of Independence, if you know?
Yeah, yeah.
If you read through his
you're
notes.
thinking of 1916, is that right?
Yeah.
Yeah, in 1916 he was in London.
Okay.
Because
there was nothing in his notes?
No, there isn't. No, he was an artillery colonel. I mean, in World War I, he wasn't actually on the battlefield. We have come across some of his notes where he was calculating the trajectory of shells. So he was back in head office, as it were, but he was in London at the time. I mean, I'm sure he was taking an interest in it, but he. You know, in the sense that he had, I mean, he didn't own any property in England. He wasn't one of these absentee landlords or something like that. So, like when World War I was over, he came back to live in Ireland, and he lived in Ireland through the War of Independence. But he wasn't here for the 1916, which I think is what you're talking about.
Yeah. Okay. Thanks, Joe.
Yeah.
Okay, there doesn't seem to be any more questions, unless there's any stragglers there. Yes, Frank McCurry. I'm just going to mute you now, Frank. You just...
Yes, Frank is from the CCMI, yeah.
Yeah.
You're muted, Frank.
You just need to mute yourself there, Frank.
Muted now, okay?
There you go.
Yeah.
You're good to go.
First of all, Joe, fantastic talk. And I thought I knew everything about Colonel Dennis. But I think you put the whole thing together so well. And, you know, just to indicate the kind of breadth of his interests and how meticulous he was, how he pretty well much built everything himself. And, you know, his X-ray work, his work with early recordings, it's just the more we dig, the more we find out about him.
Yeah. And Frank, as you're talking there, I mean, do you have any time? Well, I suppose there's no point in asking anyone about a timeline for anything now because we don't know what we can do. Isn't that right? I'm sure you would have hoped at this stage that equipment would have been on display.
We should have had it some months ago, but as you understand, we're in a totally unknown situation.
Yeah, no, absolutely.
There is one thing you didn't mention, Joe, and that was the Dennis detector.
Yeah. Well, the Dennis detector was one of the crystal detectors. I think it was the Dennis detector was tellurium and zincite was the semiconductor he was using there, which I think he found particularly successful. He seems to have got some credit from that from the UK authorities, I think.
Well, I think it was used by the Navy for quite a few years.
Okay, yeah.
And it was actually named the Dennis detector by the Navy, which was pretty unusual.
Okay, yeah, that's right, yeah.
And in fact, I actually have one of them here. Okay. If you'd bear with me for 10 seconds, I'll bring it over.
Yeah, sure, yeah. Yeah, that's interesting. All right.
Now, here we are.
Yeah.
And if I open it up, you can see there are actually 3 sets of detectors in it.
Okay. Yeah.
He had a huge collection of minerals, I think something like 100. And as you say, he was trying different pairs to see how they would work.
Yeah. Yeah, well, I think it was tellurium and zincite was the
I think it was in this particular one. Yeah.
You decided on for that. Yeah. Okay, so it's a lot of all we have to do for our detectors is just order them online or something like that. So there were different days, weren't they?
Well, I think the people in the Navy thought he'd got someone to make this for him, but he actually made it himself, apparently.
Okay. Yes, as well as being into electronics, I probably should have mentioned, like we saw lathes and various things like that there. I mean, he was into, I don't know what you'd call that sort of, an engineer, metalwork sort of thing, so he was handy with his hands in every way.
He was a true engineer.
Yeah, that's right, yeah.
Could I ask Frank to just elaborate on what the Dennis detector was exactly, or?
Well, basically, it's a crystal detector consisting of 2 minerals. Mm-hmm. And you can see in this particular model here, there are 3 separate detectors, and you can actually rotate it to pick the one with the most sensitivity.
Mm-hmm. And what was it employed for? Sorry.
These were used as actually detectors on receivers on battleships.
Okay.
And there are a number of reports from, I think it's from the torpedo school, where they describe the work on these.
Thank you.
Thanks, Frank. Any more questions there, guys?
I must have given all the answers.
You must have been so comprehensive. In fact, fair play to Robert as well, because he helped out.
Yeah, that's right. Yeah, I'm not.
And yourself getting all that stuff together. Robert digging out the pigeon shack.
Yeah, no, he did a lot of the hard work, and he was down there many more times than I was. So he's not here tonight, but anyway, I'm sure he'll look at it later.
Yeah, we have a question from Martin. Go ahead, Martin.
Hi, Joe. Great talk. Very interesting. I was wondering, did you have to do any study around trying to figure out what all those minerals, what the real, I guess the proper periodic table elements were from the original names that they used back then?
Well, I don't think the names have changed, but I had come across some things like zincite, obviously silicon, molybdenite I would have been aware of. Tellurium was a new one on me. I had to look it up. And so was cassiterite, actually. I hadn't heard of it before. That's tin, so that would have come from, is it Cornwall or something like that? It's a tin oxide. But I mean, I mentioned when I was showing that page, Martin, that, some of the, or in fact, many of them we would be fairly familiar with, graphite, galena, silicon, some of them are selenium-like, and then there was molybdenite, which I'm well aware, well, I am sort of aware of, but as I said, tellurium was new to me, and cassiterite. So I had to Google them to find out what they were, but he obviously knew what they were. All right, yeah. They seem to be mainly oxides or sulfides or something. That's what they were. So I mean, I don't know whether you just pick them at random. I mean, in terms of deciding what would be a good, what combination would make a good semiconductor. I'm not sure whether he picked them at random or what the source of his information was.
Yes, yeah. I remember being in the British Museum, the one where the dinosaurs are. They have at the top floor, I think they have a huge room which hardly anyone ever goes into, as far as I could tell from being there once or twice. But they have all the minerals that they collected during that period of time, all labeled and all weird names, but they've rows and rows and rows of them, you know.
Yeah.
So that could be in one source he was able to tap into.
Yeah, but I'm guessing that there probably were laboratories, playing around, because I mean, I think it was, the Coherer as a detector was a very inefficient thing. It's mechanical, as it were, and then the electrolytic detector used platinum, which is difficult enough to come by, and I don't think it was terribly sensitive. So it was realized at a certain stage that a semiconductor is what you needed to demodulate the electromagnetic waves, and that needs two minerals. And I'm sure there were laboratories experimenting with it, and I suppose he had the advantage that he was interested in radio receiving on different frequencies, so he was able to try them out. And he also had the knowledge of of how to put it's really a crystal set, how to put a crystal set together, the inductor, the condenser, and all of that. So I suppose he was able to maybe do some more work and bring it a bit further than the laboratories.
Yeah.
Thanks, Martin. Thanks for that. So do we have any more questions? Roddy's just saying 73, so next time. All the best, Roddy.
Okay.
And thanks to Joe and the IRTS for a wonderful presentation and all your hard work preserving this fantastic story. And that's from GI7KAW David.
Yeah.
Any questions, guys? You can put your name in the chat, and I'll come around to you then. No, I think you've covered everything, Joe. Comprehensively, may I say?
Okay, that's fine. Yeah.
Yeah, we all good.
Okay.
Okay, take it away,
That's
Adrian.
good, yeah.
Thank you. Thanks, Joe.
Okay. Thanks, Joe, and thanks everybody. And in a second, we'll just let you all unmute and chat to each other. But just to remind you, for next Monday night, not Tuesday night, 95% sure at this stage that we'll be doing a talk for Science Week, which is backed by Science Foundation of Ireland, Dublin Maker, and DCU. It's really just a beginner's talk on decoding weather satellite images, just as part of Science Week, and getting people involved in, I suppose, STEM and radio communications. And that's at 8 o'clock next Monday night. As soon as the details for the links are up, we'll put them on the club Twitter and Facebook. And the video is already made, so it's just a Q&A session after that. So once again, Joe, thanks very much for the fascinating talk and the wealth of research that went in behind it. I'm sure it was some undertaking to do that. And you're now all free to talk to each other. You can unmute and chat away.
By the way, Adrian, yeah, that link, if you're not on social media, how do you get that link? Because it won't be the same link as this, isn't that right?
No, so you could see it at Dublin Maker or Science Foundation Ireland. But when we get it, I'll put it into our internal club email as well.
Yeah.
And we'll get it out. Hopefully I can get it in for the IRTS news on Sunday as well. Yeah. I'm just waiting for confirmation on that.
Yeah.
Okay. Thanks, guys.
Yeah, thanks.
Just a note here to Joe and the SD Radio Club, a really great, interesting night from Esther and Ian, EI4KT. And absolutely first class, Joe. Thanks from Mike, EI3 Delta Yankee. Okay. Certainly was very interesting, Joe.
It was very interesting.
Yeah. Oh, it was fun doing it as well, and I'm sure that there are some more interesting things in it that I just didn't get around to.
I think it's fascinating the way the guys at the time had to go and actually manufacture their components, everything, from the ground up. We have it so easy now, really. Well, all we do is give it out about propagation.
Yeah. But it's interesting that they struggled with the regulator then as well.
2 regulators at one stage. Yeah.
Yes, that's right. Yeah,
that's really interesting, actually.
Yeah. That was. I mean, that was news to me now. When I discovered that.
Yeah.
Do you think there's further insights into that, Joe? As to,
I'm sure.
What was it? A general, probably defence competence that London wanted to retain, or something like that?
Yeah, could have been. Yeah, I mean, they did. You see, they did control a fair bit. I mean, they controlled the waters around Ireland and the foreign affairs. So it was, and clearly that was. I mean, it should be a minor thing, but that was on the list of things that they controlled. So it was. So they had, the authorities here had the power to grant licenses for people to transmit within the state, but not outside the Free State.
I'm sure there was signal leakage.
Yeah. No, but it was in terms of talking to people outside the state, I suppose. Yeah.
For sure, someone has to be listening as well.
Well done, Joe. Very good presentation there. Well presented and well researched and done out. Fantastic stuff altogether. And finally, on the at the time, I suppose there was nobody making components, so you had to make your bloody own. That was the way it went. there was no RS suppliers or primer valves or anything like that at the time. They all came in later.
That's right.
But when these guys were doing the stuff, it was get out the tin plate, cut with the shears, cut it out, make the elements for your capacitor, wind your coil,
Yeah.
that kind of stuff.
Oh, Joe, you could do that still, couldn't you?
Of course I can. I do it every week. But they do. There was no such thing as having plastic water pipe to wind the coil on. You had to sort of like a prefabricated thing. A lot of them used not wood, but cardboard with varnish, cardboard and yacht varnish or whatever it was used on boats at the time. Some kind of tar substance, and develop around a pole to make a former for a coil. And once it hardened and was set rigid, of course, it was absolutely ideal. But that's the way you did it, and it was. But all that stuff is very good. And the thing that pushed. What the hell is that?
You tell us.
We're talking there somewhere along the way. Anyway, but that's the development of that particular type of stuff was all done by military organisations. They got very interested in the electronics part of the radio spectrum. They were very much interested in getting stuff done, and they put billions and billions of pounds and dollars and all kinds of stuff into it to get the stuff done. They have to expect teams of people to work out stuff like that. So after the amateur started it, the military people got really involved. A lot of the advances that were made involved technology and all that kind of stuff was all down to military people trying to get one up on each other. Look, we built this detector, and you can hear it get a signal for over 5,000 miles away and all that kind of stuff. And they decided then they were interested then in getting into shipping. And of course, the Admiralty, the Admiralty in London are the people who invented the Q codes for transmission by naval ships at sea. And the reason they were invented was to save long drawn out use of the marsh key. So instead of sending out a whole sentence of stuff, you just sent out a Q code, which had a meaning to everybody, and everybody else understood the meaning. And of course, as aviation took off, then they transferred the Q codes to area stuff as well. So you had some of the codes were duplicated in area stuff, like the ones for distance from station to station, where you are, your location, all that kind of stuff was all done on aircraft as well as on ships. So that's the way that went down. And so fortunately, a lot of those things now are gone by the board. I think lots of people don't actually know. Actually, people using Q codes or something that don't actually have any meaning at all.
Oh yeah.
In real terms. So people making their own, putting their own particular spin on what was a Q code that meant something. It doesn't mean anything at all. There was just a lot of gobbledygook. Oh, that's the story. Great talking with Joe. Well done.
Thank you.
Sure what I said, somebody boy?
Joe's up.
Sure I said, this is Echo India 6 Echo.
And company.
Hello, everybody. I don't know if you can hear me. This is Tony. Well done, Joe. Done a great presentation. And hello to everybody. I hope you can hear me.
Do you want to give me a call when you get?
Yeah. Thanks, Tony.
Oh, you can hear me. God,
okay, now you can hear, and we can see you. We can see you.
I'm just saying, I've done a